Now, before diving into the main content, first of all, I want all of you to write in the chat box the language that you are using in this bootcamp. It can be C, C++, Java, or Python. So write in the chat box the language that you are using for this bootcamp. Okay, C++, Java. Great. Okay, so we have already told you that in this, the code will be in C++, but it doesn't matter because the concepts will be same for all of the language. So according to your language, according to your preferred language that you are using, you just have to modify the code according to your language. Just the syntax will be different, but the main concept, the main algorithm behind that will be same. Okay, so with that said, let's start the session. So I want Shreya to start this session.
Yeah, so hello everyone. Today we'll be starting with our very first data structure, that is array. So what is an array? Array is basically a linear data structure and it is a collection of items having same data type. Like if we're storing integer values, it have to be only integer values. We cannot store character values inside it. So these items are contiguous memory locations, that is one after another. And these exist using something called indexes, which starts from 0 and it goes up to n-1, that is 1 less than total number of elements in the array. So now array can have one or more dimensions. Let's see how you can declare an array. So the first method is you can declare it by specifying. You can just write the size in the square brackets after the array name. And secondly, you can declare it by initializing the elements. So you don't have to specify the size. You can just initialize it with elements in the curly braces. The third way you can initialize it by specifying the size as well as initializing the elements. So in this method, the number of elements in the array have to be smaller than or equal to this size. Here we have 6 elements and the size is also happens if we have 4 elements, but the size we have given is 6. The size is less than the size that we have initialized. So what happens in this case is the remaining elements will be initialized as 0. After this 1, 2, 3, 4, 2 zeros will be initialized in this array. Next we have taken this array. The name we have given it is R and the elements are 1, 16, 12 and so on. So as you can see, there are 7 elements. The indices are from 0 to 6. That is 1 less than 7, 1 less than the number of elements in the array. So here we are storing the integer data type inside the array. Integer data type has a size of 4 bytes. So each of these 7 elements will be occupying 4 bytes of memory. The total memory allocated to this array will become 4 into 7 into 4. That is total number of elements into the size of data type we are using. So this becomes 28 bytes. This much memory will be allocated to this array. Now the elements array, these are accessed by using indexes. How you can access these? You can just simply use square brackets and you add the index inside it. For example, we've written add 2. So this will return the value stored at index 2, that is 12. Right. So next we can talk about memory allocation. Here we have taken an array that is 4 to 7. So we have 3 elements inside this. Now the integer 4, the first element of the array, will be stored at index 0. It will be taking 4 bytes. Now we'll come to second element. It will be stored at index 1. It will again be taking 4 bytes because it is of integer type. Same is the case with integer 7. So what we want to say is, if this array is starting at the location 2000, then the first element, that is integer 4, will be stored at location 2000 to 2003. The next element, that is integer 2, this will start from 1004. And the next element, that is 7, this will start from 2008. So the total memory allocated to this array will become 3 into 4 is equals to 12 bytes. Next, we have types of array. So array can be a single dimensional array. It can be two-dimensional. Two-dimensional array is basically multi-dimensional only. So let's see what an 1D array looks like. So you just initialize the one-dimensional array using one square bracket, and inside it you write the size of it. 1D array, we just use a single row. We don't have single row and multiple columns here. So each element can be accessed using the index of it. For example, we can use, here we have the name num. So we can use num5 and it will return the value 2. So for multi-dimensional array, we can have two-dimensional arrays, we can have three-dimensional, and we can have even more than three-dimensional. So first, see what is two-dimensional array. So these square brackets basically specify the number of dimensions the array has. So here we have two square brackets. First one specifies the number of rows and the second one specifies the number of columns. You can see we have 1, 4, 2. This is the first row, and 3, 6, 8. This is the second. So number of rows is 2 and number of columns will specify the number of elements inside the rows. So you can also take a look at this table representation of the array. So what if you want to print this element 2 here? So if you want to print this element, you have to first take the name of and then take the row number. This is in row 0. So the first bracket will contain 0 and the second will contain the column. So multi-dimensional array, it's not possible to visualize it, but you can see it is declared as this. This is the basic syntax. The first thing you need to specify is the type. It can be integer, character, or boolean, whatever. The next is array name, whatever you want to name your array. And then these square brackets, inside these, you write the size of the dimension. These square brackets are the dimensions. So suppose you have n square brackets here, it will be having n dimensions. So it can have multiple rows and columns. Again, this is an example of 2D array only. You can see it has two. Oh, I guess there is some problem here. It should be 3. Instead of 2, it should be 3. So 3 rows are there and 4 columns should be there. So you can see 3 rows and each of these rows contains 4 elements inside it. So there's a simple question. I would like you all to answer it in the chat box. So you have to tell if this is an array. No, right. Right, you're right. This is not an array because it is containing a string as well as integer as well as a character. So we are ready to solve a question now. Let me share my screen. Don't have similar data types, no. Right, Anmol. So let's solve a question now. The question we are solving first today is sort colors. So let's see what this question says. First of all, it is given an array nums. So this is the name of the array with n objects colored red, white and blue. Sort them in place so that objects of same colors are adjacent with colors in order red, white and blue. So what this is saying is there is an array. It contains n objects and the color of these objects can be red or white or blue. And you have to sort them such that the red colored objects are placed before, after that white colored objects and after that blue colored objects. In the next line, we can see we will be using the integers 0, 1 and 2 to represent the color red, white and blue respectively. So basically it has assigned 0 to red, 1 to white and 2 to blue. So what we are doing here, we are just sorting the array of 0, 1s and 2s. We'll be having an array like this. You can see an example. In this array, we just have 0s and 1s and 2s. When we just have to sort it. Now, you might think we can just use library function for sorting, but it is given in the question you cannot use library sort function. So you have to sort this array without using the sort function. So any idea how you can solve this? No? See, we are just having 3 integers here. We just have 0, we have 1 and we have 2. So what we can do is we can count the number of occurrences of 0, we can count the number of occurrences of 1 and we can count the number of occurrences of 2. And after that we can update this array such that you can see the number of zeros here is 2, 1s as well as 2 and 2s are also 2. So we can just update this array such that first 2 numbers are 0, next 2 are 1 and the next 2 are 2. So let's see with the code. You can take 3 integers, count 0 will store the number of occurrences of 0. You can take count 1. You can initialize all 3 with 0. So all these will store the number of occurrences of 0s and 1s and 2s in this array. So now we have to traverse this array to count the number of occurrences, right? So we will start from 0th index and we will go up to nums dot size. You can do I plus plus. What we are doing, if we are encountering nums I equal to 0, so we can do nums we are incrementing the count of 0 by 1, right? So this means कि हमें एक 0 मिल गया, हमने count 0 की value 1 बढ़ा दी. Else, if nums I becomes 1, we can increment count 1 by 1. Or it can be is equal to 2. Can we do? So we can increment the count by 1. So at this point, we have calculated the number of occurrences of zeros and ones and twos. If you take the first example, this at the end of this loop, this will be 2. Count 1 will be 2 as well. Count 2 will be 2 as well. Now what you have to do, you have to update this nums array. Since it is saying in place, so you cannot use another array. You have to update this nums array only. So again, you have to start the loop int I equal to 0. From 0, you have to start first 2. That is, you have to write first 2 elements as 0. So count 0, I plus plus. We just write nums I equal to 0. What this will do will give us an array 0, 0, right? And the rest you can just forget about it for now. The next loop. Now the next loop we cannot start it from 0 because we have already updated these two values. So we have to start this from count 0. Count 0 and count 0 plus 1 नहीं लेना यहाँ पे क्योंकि over here we have just updated the values before count 0. So we have to do count 0 plus count 1. I plus. So we have taken this because देखो यहाँ पे count 0 is this one and count 1 is this one. So we have to calculate this much. Let's just update nums I equals to 1. And similarly, you can do for where you have to start from count 0 plus count 1. And you have to go up to count 0 plus count 1 plus count 2. Okay, so this will cover all of this. And you can just write nums I equals to 2. Now we can check. So it is accepted. I hope this much is clear. Can we do it as inside the loop? Push back 2 at the end of the vector and 0 in the beginning. Push back 2 at the end of the vector. Yeah, right. We can do that as well. Anmol. There is also another approach I would like to share with you all. This. So is my screen visible to you all?
Yes, it is.
Right, it was given in the question. So what we are doing in this approach is we are using 3 integers, that is mid, low and high. So what we want to do, we will initialize 0 to low and we will initialize high as 5, that is the highest index, right? So and we will use mid to traverse all of this array, right? We will do this until this mid and high crosses each other. Now think about it, we're just sorting 3 values and we can divide it into 3 parts, low, mid and high. So while traversing this array, if you encounter 0, what we want to do is we want to shift it towards the left side, towards the indexes, right? So, and if we take this 2, if we face this 2, we want to swap it to the higher indexes. So there can be 3 cases. We can either get 1, we can either get 0, we can either get 2 while traversing this array. So let's see. Case 1, as you can see, what we are doing, if the mid value of nums is 0, while traversing the array, if we encounter 0, we can just swap this mid value with the 1 at the low value. And we can increment low and mid by 1. Case 2 could be, it can be 1. In that case, we won't swap it with anything. It will eventually end up in the middle. We'll just increment the mid by 1. Case 3 could be 2. And we just have to swap this mid and high. And after that, we'll decrement high by 1. Let's see with an example. So here I have initialized low and mid by 0. We will be starting in the starting index and high at the highest index. So we will be checking the value for mid. So mid here is 0. So nums 0, you can see 0th index pe it is 2 value. So we have encountered 2. This is case 3. So what we were doing in case 3, we were simply swapping the mid and high value, right? And we were decrementing high by 1. What we have done, mid is 2 and high is 0. So we have swapped here. 2 comes here, 0 comes here, and 4 high is decremented by 1. So what this high means basically is the array after this high is sorted. This is the highest index which is unsorted. So next, again we will check the mid value. It is 0. Again it is 0. This will be case 1. Whenever we get 0, we will swap it by low and we will increment low and middle by 1. So this low and middle will be incremented by 1, and since these are both at 0th index, there won't be any change. And we will just increment it by 1. So here again we will check mid value. Here again it is 0. So again it is case 1. We just want to swap this value with the low value. So again this low and mid value are at the same index. So there won't be any change in here, and we will just increment low and mid by 1. Next we will check mid value again, and this time it is 2. You can see low is pointing towards second index and it is 2. So this is case 3. We are getting 2. So we will swap mid by high and we will decrement high by 1. So you can see mid 2 and high 1 are swapped. Here 1 and 2 are swapped and high decremented by 1. So you can see here 2 and 2, this is a sorted array. You don't have to worry about it. And similarly over here, the 0, 0 are at correct places. Next, we have again to check this mid value. It is 1 here. So when it is 1, we don't change anything. We will just increment the mid value. So when we increment the mid value, it becomes 3. And now see, this becomes equal to high, right? We have to check it one more time. This again is 1. So there won't be any change again. So I have not written here. But after that, it will be crossing and we don't have to do anything. You can see the array is sorted now. So this reduces the complexity of this thing. Let's try to code it. Int, we have taken low, we will initialize it with 0. Int mid we have to take and we will initialize it with 0 as well. int high, we have to go to the highest index, right? So nums size minus 1. So what was the terminating condition? It was mid should be smaller than equal to high. Right? And what we were doing, if nums mid was equal to 0, what we were doing, we were swapping nums mid with nums low. And after that, we were incrementing low by 1 and mid by 1. Else, what else we can get? We can get nums mid equals to 1. In this case, we were not doing anything. We were just incrementing mid by 1. Else, it was 2. It is understood. You don't have to write it. So swap. What we have to do? We have to swap nums mid with nums high, right? And then you have to decrement high by 1. Let's see. Submit it. So it is working. Right, so this was to lead you on to the next question. Akanksha is here. If you have any queries, you can ask. Okay, so to lead you on to the next question, Akanksha is here.
Okay, thank you, Shreya. You can now stop the sharing. Is my screen is visible to all of you?
Yes, it's visible.
Okay, so just let me know whenever my voice cracks up or my screen is not visible. Okay, so this is the roadmap. This is the roadmap that we are using, and today I have chosen this question, the maximum subarray. Now, the reason for me choosing this question is that there is an important algorithm behind solving this problem, which is Cadane's algorithm. And this question and this algorithm have already been asked in many big companies like Amazon and Microsoft. So we are going to understand this today. So first of all, let's see the problem statement. So the question is maximum subarray. The question is, given an integer array nums, find the subarray with the largest sum and return its sum. Which means that you are given an array and you have to find a small part of the array, that is a subarray, whose sum is maximum. Okay, so that is the question. Let's see with this. So I have taken a small example for this. Okay, so this is the array. Now, as you can see, this array contains both positive and negative element. And from this, you have to find out a small subarray whose sum is maximum, right? So if I have to say, see, if this is the array, the maximum sum which I can get is from this part, from 4 to 5, 12, right? See, in this, there are other examples also. This is the array. And the maximum and the subarray, which is giving us the maximum sum, is this one, this part. The sum is, output is 6. Similarly, in this case, there is only one element. So what will be the output? That element itself, 1. And in this case, the subarray is going to be the whole array, and the largest sum we are getting is 23. So let's come on to this again. So basically, to solve this question, there are multiple techniques, and those of you who are doing along with me, they already have come up with some of the techniques till now. So, but I have to say that the most efficient technique to solve this problem is Cadian's algorithm. Now, I will talk about it later on, but first, let's see the brute force solution. So, to do any question, brute force solution should come into your mind first. Okay, only then you can move towards the optimized path. So see, so the problem here is of subarray. So whenever there is a question of subarray, you need to see, whenever there's a question of subarray, first of all, you need to find the subarray. First of all, you try to find all the subarrays in the array. What I mean to say is, if there's a question of subarray, then try to find out all the subarrays. So here in this array case, the first subarray should be -4 to 4, right? Just let me change, see, okay. -4 to 4. The second subarray should be -4 to 4. Third is -4 to 6. Then -4 to 3. Similarly, -4 to 5, and then -4 to 2. These are all the subarrays which are starting from -4. Similarly, if I see, the subarrays which are starting from 4 are 4 to 4, then the next is 4 to 6, similarly 4 to -3, 4 to 5, and 4 to -2. So this is so this is all like, so these are all the subarrays. So in this question, for the brute force approach, we will first of all find all the subarrays along with the sum, and from all those sum, we will find the maximum sum. So whatever the maximum sum is, we will just return it. Okay, so let's just try to code this brute force part. My screen is visible to all of you now. Shreya, just let me know whenever the screen is not visible, okay?
Yeah, sure.
Okay. So the brute force part is what I just told you. We are going to traverse the array. So first of all, I want you to ask, to find all the subarrays, what is the approach that you are going to use? What you should use to find all the subarrays? This is a very simple one. Okay, to find all the subarrays, what approach you are going to use? This is a very simple. You just have to use 2 loops. See, we will just use 2 loops here. Let's start with initializing. Let's take the max sum. Now I am initializing it with int min. What is int min here for the C++ student? You already know. Int min, this is the minimum value for any integer to have. So I'm storing the minimum value here. Okay. So and we will just return this max sum in the end. So I'm using 2 loops, 2 for loops for creating the subarrays. Int I is equal to 0, I less than, let's take the variable n here. Int n. What is this n here? The size of the array. Okay. So instead of writing nums.size, I will just use n. Now, I'm initializing a variable again, int sum, which is 0. Now this sum is what? This sum is actually calculating the subarray sum. Okay, all the subarrays that we are creating in this. And again, I'm using for loop here. And this loop is gonna start with I. Sum plus equals to nums of j. See, the code for brute force is very simple. We are just using 2 for loops and that's it. And in the end, we are just comparing it. So here we have just initialized this sum variable, not sum, max sum. Okay. So here what I have done is initialize the max sum with the minimum value, and then I'm just using 2 for loops. The sum is storing the subarray sum that we are getting at each iteration, and I'm just adding the nums value here, and I'm comparing in the end by the if condition that if sum is greater than max sum, then I'm updating the value of max sum, and in the end I will have the maximum value. So let's see whether it's working or not. For those of you who are using this CPH extension, you just have to, when your code gets completed, you just have to, the shortcut key is Control plus Alt plus B. Then the screen will just pops up, okay? Let's take the same example which I have used. So here the number of elements are 6. And the values are -4, 4, 6, -3, 5 and 2. Let's see. The answer should be 12 because we know the maximum sum which we are getting is from 4 to 5, right? Okay, it's 14. Let me see whether the code is correct or not. I'm starting with int I equals to 0, initializing the sum, then starting the j with I, j less than n, okay. The sum should be 10 plus 5, 15, and 15 minus 3, which is 12. Can anybody find the error here? Yes, the last element is -2 maybe. Yeah. Okay, -2. Okay, yes. Thank you, Assist. So the last element is -2. Here, this is the 4, 6, -3, and 5. So this is the maximum sum which we are getting from this subarray. Okay. From this subarray, from 4, 6, and 4 to 5. Okay. So now over here, we can see first of all, what is the time complexity of this? What is the time complexity of this brute force solution? Just let me know in the chat box. Big O of n square, right? Why? Because we are using 2 for loops, which are running, first for loop is also running from 0 to n, and the other one is also running from I to n. So the time complexity here is big O of n square. So I haven't submitted this code to the lead code yet for the brute force one. So let's see whether the lead code is accepting our code or not. I don't think so because the time complexity is already big O of n square. Let's see. And the constraint, line number 28. Let's try to submit it. Time limit exceeded. That's what I was expecting. The TLE errors are shown. So let's try to optimize this solution. Okay. Now, let's take a smaller problem. Let's take, we have an array A and only 1 is there. So this is the smaller problem. So what will be the answer? If our array contains only 1, what is the maximum sum which we can get? 1, right? Now let's assume along with the 1, we have 2 also. So now what is the maximum sum which we will get? 1 plus 2, which is 3. Correct? Now, if I say my next element is 5, the answer is simply 5 plus 2 is 7 and 8. The answer is 8. What if the last value is 100? Then it's gonna be 108. So did you notice one thing? You can understand one thing from here, that if all the array elements are positive, then we can just do the sum of all, and that is our answer, right? Like if I keep bringing on all the positive element, let's say 1 also, and let's add 2 also, my sum should be just the sum of all the array elements. But where the problem arises? But the problem comes when we had a negative element in this. Let's take the same example. I have 1, but my next element is -2. Now, the maximum sum that you can get from this array is 1, right? The maximum sum which I can get from this array is 1, right? Because if I included 1, if I take the sub array 1 and -2, the sum I will be getting is -1, which is negative. But the maximum sum I can get is 1. Okay, let's add 2 here. Let's add 2 here. Now, I want you to tell me what is the maximum sum which I can get from this array. Two, right? Okay. The maximum sum now I can get is 2. See, someone has written the 3. No, we are choosing the sub-array. Sub-array is what? The continuous, the consecutive values, right? The sub-array is -1 and -2. This is the sub-array. The sub-array is -1, -2, and 2. This is another sub-array. Subsequence is what? When you chooses only 1 or 2. If in the question, if I was asked instead of sub-array, the question is like subsequence. So then I can choose 1 and this 2 here. And in that case, the answer will be 3. But here they have asked about the sub-array. So for the sub-array, this continuous part. So we have already seen, if I just choose only this one, the answer would be 1. But if I choose this sub-array, the answer is gonna be -1, right? And if I choose this whole array, this whole sub-array, the answer should be 0. But if I choose only this 2, this is also a sub-array, right? So I'm getting 2. Correct? Okay. Let's add some more elements here. Let's add 3 also. Now, I want you to be attentive here, because this is really an important algorithm and it has asked in many interviews as well. So now I have added 3 also. I already know if I add this part is giving me, the sum of -1, right? And this alone part is giving me 2. But if I included this 3 as well, so my answer should be 2 plus 3, which is 5, right? So this part is giving me -1. So there is no point for me to include this in this total sub array, right? So we are actually moving one by one here. Okay, so in this case, the sub array should be what? 2 and 3, because I already know this part is giving me -1. And if I take this part is 2. And if I include 2 plus 3, which is 5. So the maximum sum I'm getting here is 5. Okay, let's add another element, which is -6. And let's also add 3 as well. Now what is the maximum sum which I can get from this array? The maximum sum which I can get from this array, tell me. Yeah, the answer is 5, because if I add 5 and then this part will give me okay, so this part is giving me 5, but if I include this part also, this part will give me what? -1, right? So this part is giving me a negative value. So in this way, we are moving one by one. Now, you can understand one thing from here. The moment our sum becomes negative, the total sum becomes negative, we are just going to discard that part. I'm repeating it again. If any part of any subarray, the sum becomes negative, then there is no benefit of including that part, right? You have already seen here, this part is giving me -1, which is the negative part. So instead of including this -6, I'm just staying here. The answer should be 5. So the basic trick for Cadine's algorithm is that we keep on moving ahead. We traverse the whole array, but the moment our sum becomes negative, the overall sum becomes negative, so you discard that part and start the same story from the next element. You will understand it more clearly once I code, and I will also dry run this code as well. So let's try to solve this. Let's initialize the variable first. Int maxsum. This maxsum is gonna store our maximum sum of the subarray. Let's take int min. Okay, and let's initialize the sum variable to 0. Right. We are traversing this for loop for int I equals to 0, and so what I'm doing here is, in every iteration, I am adding the nums value in the sum variable, right? But, okay, so if I'm checking if sum is greater than the max sum, I will update my max sum variable with this actual sum. And if this is the handy part where the array stores the negative values. If sum is less than if sum is less than 0, which means now our sum stores the negative value. So we are just going to discard that part and move further, right? And in the end, what we are doing is, We are just returning the max sum. So let's see the test. Let's see the test case. Okay, let's see these test cases as well. Comma greater. Minus 1, 2. Next value is 1, 5, and 4. This is minus 5 now. And the total number of elements here are 3, 4, 5, 6, 7, 8, 9. The answer should be 6. Okay, so we are getting it. So let's first dry run it. I'm sure most of you still have doubts. So let's dry run it. Okay, so this is my code and this is the array which I'm taking. Okay, so in first step, max sum is initialized with int min. So here, max sum is initialized with int min. And sum has 0 value. The sum has 0 value. Okay, first iteration, I equals to 0. See, at I equals to 0, the value of array is minus 4. At 0 index, our array stored what? Minus 4. So I am adding the value of array in here, sum plus equals to nums of I, which means now sum will be updated to minus 4. Now, these if condition, which if condition is gonna applied here? See, sum is less than 0. Sum is less than 0. So in this case, since the sum is less than 0, our sum will be initialized to 0. So I'm updating my sum to again 0. Since there is no benefit of us including a negative value, since we want the maximum sum, right? Now the next iteration. Now I equals to 1. Here I equals to 1, and at 1 our array store 4, right? Our array store 4. So here again sum plus equals to nums of I, and the value we are updating here is sum equals to 4. Now let's see. Our max sum contains int min here. So sum has the 4 value and the max sum has int min value. So we are updating the value of max sum. So now our sum equals to 4 and our max sum is also equals to 4. Now the next iteration, I equals to 2. At I equals to 2. Sum. So our sum has already stored 4 in it. And at I equals to 2, we have 6 value. So sum will be what? 4 plus 6, which is 10. Now again, the max, so here this if condition is gonna applied, this sum is greater than max sum, since the max sum has 4 and the sum contains 10. So we'll update the value of max sum to 10, correct? Now, the next iteration is I equals to 3. I equals to 3, our array store what? Minus 3. So our sum will become 10 minus 3, which is 7. 10 minus 3, which is 7. So here, दोनों में से कोई भी condition applied नहीं होगी, since our sum is also not less than 0 and our sum is also not greater than max sum. So we will just move towards the next iteration, which is I equals to 4. Now at I equals to 4, our sum has what? The value of sum is now 7. So in 7, we will add this 5. Okay, since at the 4th index, our array store 5 value. So we'll just add 7 plus 5, which is 12. Now the max sum contains 10 and our sum has 12. So this if condition is gonna applied, sum is greater than max sum and we will update the max sum to 12, correct? The last iteration is I equals to 5, and at I equals to 5, our array contains minus 2. So here our sum contains 12. So 12 minus 2, which is 10, and the max sum contains 12. So no if condition is gonna apply, and we will just come out of the loop and return this max sum. I hope with this dry run, you understand what is the basic algorithm, what is the concept behind this cadence algorithm. Let's copy this code and try to submit it on the lead code. Okay, so our question have already passed all the test cases. So that is what cadence algorithm is. And the time complexity, first of all, what is the time complexity for this? What is the time complexity of this problem, of the solution? N, right, big O of N. Okay, so we have come from big O of N squared to big O of N. So this is what the cadence algorithm is. Okay, so this is what the cadence algorithm is. So these are the all 2 questions that we have to do in today's session. That is all for today's session.